we use the EPRI as our sort of like gateway, collecting all of the data. We have other sensors available, so if you like that sort of information, do contact me and I can put you in touch with that data. So we did this, 20 houses, and sent them all to our database at Glasgow. We also used the current cost IAMs for the sub-metering of appliances. And yeah, it all ran reasonably smoothly. So we have quite a lot of unique timestamps and lots of total readings. Only 6.4% of the data dropped out and was given NaN readings. The IAMs, the current cost IAMs, basically have an issue sometimes where they report much higher spikes than what's actually possible with the hardware they have. So it will be like 21,000 watts for a plug, so unlikely. So on average, each one only had about 250 errors readings. So it wasn't too bad, it worked out quite well. Out of the 20 houses, 3 of them had solar panels, which couldn't be rewired, which means that the aggregate data for those houses has this sort of curve in the middle, which is maybe useful for, I can't remember who it was yesterday saying that they could disaggregate through solar. So it might be interesting if they want to look at that. On average, we sub-metered about 46% of the total consumption of the houses. In terms of the cleaning in the data set, so there's a clean data set and a raw data set. So the clean data set has daylight savings correction because someone didn't set some of them up correctly, the VIRs, removed the NaN values and stitched together IAMs where the consumers basically moved the appliances around and didn't tell us, so I had to go through and do it afterwards. So this is based on the HES results, so it shows you all of the appliances in each of the houses that we monitored and gives you sort of overview of all the things. So as you can see, we monitored a lot of televisions, a lot of washing machines, as they're quite high consumers, dishwashers, kettles, toasters, computers, things like that. And you can see the sub-metering for each of the houses. The 3 houses of solar panels that affected the overall consumption don't have values there, but you can see it's all sort of around about high 40s for lots of houses. Here's all the uses. I went through and did this quickly, so these uses are probably not like exactly representative, but you can see there's quite a lot of stuff that you could take out appliance signatures from. So obviously a lot of people here are working with like very high frequency data. This is obviously 8-second data, but it still gives you quite good idea of some of these appliances, and especially if you're training washing machines or dishwashers or something, you'll be able to see all of the different cycles that they could go through if you wanted to. And that's the overall consumption for each of the appliances, showing that we sort of like picked the right things in terms of sub-metering. This is our validation with regards to the utility meters. So obviously using the current cost, we wanted to make sure that we were getting values that made sense and ended up being like semi-reasonable at the end. So you can see most of them are pretty much in line. There's maybe a bit of deviation, but you can account that to the current cost and sort of errors values and also missing data in some cases. So yeah, less than 12% difference is not terrible. Not the best, but not terrible. This is the uptime across all of the houses. So basically, our worst house was 76% uptime since it started recording. You can see house 2 was the first one that started recording, obviously, as you go up in numbers. And then from then on, we get quite good readings from sort of March time, because we had an issue with the server during February. So if you've downloaded the data set, then you know what it looks like. But if you don't, this is just what you get. You get the date time format, Unix time, and then you get all of the appliances and the aggregate in watts. And the code used is available on GitHub at that link. So if you look at the slides later, you can get that. So what we're doing with the data set is load disaggregation. So we're doing supervised NILM unsupervised film, and a training list method with no previous knowledge on anything. It just sort of goes for it. So these again are all referenced at the end. Yeah. So this image here is showing sort of a couple of days, or I think a day maybe, an evening in one of the houses with the sort of sub-metered appliances. So you can see where the gaps are that we couldn't or didn't have sub-metered items on, which is the big one in the middle is someone using an oven, which we couldn't get around behind to actually sub-meter. So you can see it covers quite a lot of the things, especially throughout the day, but there's obviously just big appliances like this, where if they're hardwired in, we didn't get the sub-metering. But it's good for disaggregation because it means you can use the sub-metering as a sort of validation for the correct appliances being labeled. We're also doing sort of time use analysis, so identifying what people are doing throughout the day and like assigning sort of patterns to their usage. So you can see the two circular plots at the side here. The house at the bottom is like a regular house works throughout the day. There's spikes at 6 and 7, and then again at midday, and then after work time. And then the bottom house is a retired single person who basically just stays up all hours of the night. So you can see there's quite a lot of usage throughout the evening, sort of 12 a.m. kind of time. We also look at load shifting, and some other people have used the data set for demand response. I think that was an Indian paper, again in the references. So we sort of looked at, in terms of load shifting, where people were using their electricity either during the day or during the night, and suggesting which appliances, if they have any, that could be moved, and if they'd be willing to move that. We also did appliance monitoring for individual appliances, and then predicting when those will be used to help us with our disaggregation. Because if you know when it's likely to be used, you can assign better values to it. Yeah, and that helps a lot with disaggregation. And then we also did mapping of what appliances are being used to the type of activity. So obviously cooking, laundering, watching TV, things like this, that narrowing down, which we found that the occupants of the houses actually liked this more, is it sort of like, it didn't split it down into its constituent parts, which they were like, well, why do I need to know how much this is using? But if they saw it as an activity, they were more engaged in some cases anyway. So that's one way that the people there enjoyed having their electricity broken down, and then they could obviously adjust anything, or if they considered they were watching too much TV, they could change that or things like that. So yeah, the data from this data set, obviously an 8-second resolution is similar to what the smart meters in the UK will be providing at sort of 10-second resolutions. So as I said before, it's one of the largest in terms of time and number of houses in the UK at sub minute data. And it's really useful if you're wanting to do disaggregation, appliance profiling and modeling, demand prediction, use time analysis, and also load shifting stuff. And then for the benefit of YouTube, going to go through all the references really slowly. But thank you very much.